Hello students, welcome to the next video on Analog Electronics 1. Myself Gunjan Mittal Roy in the Department of Electronics and Communication Engineering in GEMTech, Greater Noida. So in the previous videos on this unit, feedback amplifiers, we have talked about negative feedback, its types and its properties. Now in this video, we will be covering the impedance part or impedance of various types of feedback configurations. So overall there are four configurations of negative feedback, which are voltage series, voltage shunt, current series and current shunt. And for all the four configurations, we will be discussing input impedance and output impedance, the effect of feedback on Zin and the effect of feedback on Zout. So the very first configuration is voltage series feedback configuration. Here it is called voltage series because the input signal applied to this is voltage and the output comes to input in series form. So if the input port is connected into the series form, and also from the output the energy what is fed to the feedback network is voltage. Now first of all, we are talking about the input resistance. So the resistance looking into the input is Rin. The input current is In. So the input resistance Rin is given as Vin upon In, or in other words, Vin equal to In into Rin plus Vf, because input port has a series load. So the KVL is applied here. Vin is nothing but VA plus VF, and Vin is given as VA plus VF, where VA is In Rin plus VF. So Vin is In Rin plus VF. VF is beta into Vout. Here we can see that the feedback voltage is the output voltage of this feedback network, and the output is gain into input, where gain is the beta factor and input is Vout here. So Vf is beta Vout, and Vout is nothing but A into Va. Output voltage is again gain into input, where gain is the A and input voltage is Va. So Vout is AVA. So if we put all the values, we get Vin equal to In Rin plus beta A In Rin equal to In Rin into 1 plus beta A. We can take In Rin as a common factor. So it is In Rin into 1 plus beta A. So finally Rin with feedback becomes Rin into 1 plus beta A. Since 1 plus beta A factor is multiplied, so Rin is increased. So here the series connection on the input increases input resistance. Next is the output resistance. So to find that, we will use the equation I out equal to V out minus AVA upon R out. Here we have the current relation is I out. So I out equal to V by R simply, and V out, V is nothing but V out minus AVA upon R out, where VA is minus beta V out. So we put the value of VA here and we take V out common, and V out upon R out becomes R out only, and here LHS is R out with feedback. So R out with feedback is equal to R out without feedback upon 1 plus beta A. So 1 plus beta A factor comes in denominator, therefore the output impedance is decreased. After that, the next configuration considered here is current series feedback, and in this case the output energy output port is connected in series. So the output port has series terminal directly connected, and the input port has also it is applying current. So it is a current series. Output is in series, and input, through input we are having current. So input resistance, as the feedback is applied in the same way as the previous topology, the effect is the same, that is because the input port is similar, in this case it is similar to the previous case. So the effect of input impedance is also similar, and therefore we get increased input impedance. So the input impedance is increased. But what about output resistance? So the output resistance is also in series connection, and the series connection brings the increased impedance factor. So the output resistance is also increased. That means in current series configuration, both input and output resistances are increased by the factor 1 plus beta A. So input increment is required, it is advantageous, but the output increment is not required. So this is the drawback. Now the current shunt, the output energy comes in is current, so it is in series, and the input port is in shunt or parallel. So in parallel the currents get divided, so the input port is in parallel and output port is in series. The current in the output port is applied, so the same current flows in series. So the output port is in series and input port is in shunt. So if we talk about the input resistance, the input port is in shunt, and we know that in shunt the impedance decreases. So the input impedance decreases, whereas the output port is in series and the effect of topology is the same, that it also it increases. So here we have just opposite impedance effect of the first case. So in the first case the input was increased and output was decreased, but in this case the input is decreased and output is increased. So it is, in both ways it is a drawback. So it is the poorest configuration in terms of impedance. Now the last configuration is voltage shunt, and in that the output port is in shunt. The output energy applied is voltage, and the same voltage is applied in shunt, whereas the input port is also in shunt, and in shunt the currents are divided or applied. So both input and output ports are in shunt, and we know that in shunt the resistance effect is that it decreases. So both input and output resistances decrease. So the decrement in output resistance is advantageous, but the decrement in input resistance is not required. So it has one advantage and one disadvantage. So here is the summary of all the 4 configurations offering different parameters, which are gain, bandwidth, input impedance and output impedance. So if we consider the first 2 parameters, which are gain and bandwidth, it remains same for all the 4 configurations, which is that the gain is increased and the gain is decreased and bandwidth is increased. So for all the 4 configuration, gain and bandwidth remains same, but the impedances, which are input and output, they vary for different configurations, as we have just discussed in this presentation. So in case of voltage series, the input resistance increases and output resistance decreases. For current series, the input resistance increases and output also increases. In current shunt, the input decreases and output increases, and in voltage shunt, both input and output decreases. So if we compare all the 4 configurations, the best configuration is voltage series, because it gives the desired change in resistance, that the input should be high and output should be low. Thank you so much.